Welcome to the planet called Matheta. As we see the planet, there is a hospital road, there is a number road, and there is count road. We will learn more about the building's operations, figures, and E&I. Here we see Dr. Math, Dr. Count, Mathet 1, and Mathet 0. Now, on the planet Matheta, the numbers are in their spacesuits. So, when they're on Matheta, 1 is now Mathet 1. 0 is Mathet 0. In the figures building, we have many figures. We will take a look at a few. Our first figure is a square. We also see another square, but it has been tilted over to the right. Our next figure is a rectangle. A rectangle has 4 sides. There's also another rectangle that has been tilted over to the right. Now you might think about this. A rectangle is not necessarily a square, but a square is always a rectangle. Our third figure is a triangle. A triangle has 3 sides. Here's the operations building. There are a lot of mathets in the operations building. We will focus initially on 2 particular mathets. There we see the Mathet Plus and the Mathet Minus. Now we see number road. Number road goes on forever. On the top of the road we have houses with addresses 0, 2, 4, 6, and 8. They're also called even numbers. And on the bottom of the row we have 1, 3, 5, 7, and 9, and they're called odd numbers. We see the house with address 0. There are 2 Mathet zeros that are shown, one in blue and one in a red spacesuit. Now, at the bottom, there is shown a way to write a 0. You start at the top and go all the way around to the left and then back up to the top, and you will have a 0 that looks like the one at the top. We see the house with address 1, and there are 2 Mathet 1s that are shown, one in a red spacesuit and one in a blue spacesuit. In order to draw a 1, you can simply start at the top and go all the way down to the bottom. Now, that doesn't look exactly like the one at the top. You can add a little bar at the bottom and a little line at the top if you would like. There's house with address 2, and there are 2 Mathet 2s. There are 2 ways to write a 2. Now, if you take the one on the left, you start over on the left, you come all the way around, make a loop at the bottom, and then come up just a little. You can make a 2 look like the one at the top. You simply go on the left, go around to the bottom, and then come straight over. Most people like to put the loop, but a lot of typewriters and computers write their 2s like the one at the top. There we have house with address 3 and some Mathet 3s. 3s are relatively easy to write. You simply start on your left, come around, make a little partial loop, then come on back around again. Now we see the house with address 4. At the bottom you will see 2 4s that are written. Now, the red line, it comes first, and then the blue line comes second. Now, for the 4 on the left, you come straight down and straight over and then make a line through it. This is the way most people write their 4s, but computers and typewriters, they like to write their 4s like the one on the right. In order to do that, you start on the bottom, come up, come over to the left, and then cross the original line and stop. Now we see the house with address 5. 5s are relatively easy to write. Remember, the red line comes first and the blue line comes second. Now, starting at the top, make a slight inclination to the left to start 5 and then make a loop. go back to the top, and come over as the blue line shows. Here we have the house with address 6 and some Mathets 6. 6 is relatively easy to write. You simply start at the top, come all the way around to the bottom, and make a loop. Here we have address 7 for the house. 7s are easy to write. Start at the top, come straight over, and make a slight loop down to the bottom. Here we have house with address 8 and 2 Mathets 8. Now, to draw an 8, you start at the top and see how the red lines go. They go all the way around and make a loop, and then the blue lines say, well, once you get to the bottom with the red lines, you come with the blue lines and come all the way back up with a loop and another loop to the top. Here we have house with address 9. We have 3 9s. We have a 9 in a red spacesuit, a blue spacesuit, and kind of a yellowish or brownish spacesuit. Look at how the 9 is formed. We start at the top and make a circle. Then we come to where we stopped and come straight down. Now this 9 does not look like the 9 that's above. You can make it a little curved at the end if you would like. Dr. Math spends most of his time at the math hospital, so he solves all sorts of problems that the other Mathets have and solves them at the hospital. Here we see Dr. Count and the house that Dr. Count lives in. Dr. Count solves all sorts of problems on counting. Dr. Math asked Dr. Count if the Mathets 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 knew what they represented. And so Dr. Count will now show us how to count objects in the big rectangle. Dr. Count goes to the circle at the left and says 1. Dr. Count goes to the next circle and says 2. Dr. Count goes to the next circle and says 3. Dr. Math goes to the last circle and says 4, and this is the number of circles in the rectangle. Now we will see if we can count the circles in the rectangle. There are a lot of them. So Dr. Count is now going to write numbers by the circles to keep everything in order. So Dr. Count started on the left and he put a 1 by a circle. Then he put a 2 by a circle. He put a 3 inside a circle. Put a 4 on the other side of a circle. And the same thing happened on the other side. He put a 5 inside the circle, a 6 outside another circle, a 7 outside another circle, an 8 inside the circle, and a 9 in the last circle. And so there are 9 circles in the big rectangle. The Mathets caught on quickly to how they represented numbers. So we see Mathet 0 standing next to a rectangle with no circles in the rectangle. We see 1 standing next to a rectangle with 1 circle. We see 2 standing next to 2 rectangles. Each rectangle has 2 circles. In the top rectangle, the circles are about the same size, but in the bottom circle we have a big circle and a little circle, but there are still 2 circles in each rectangle. Now we see 3, and there happen to be 3 rectangles, and we see 3 horizontal circles, a different shape of 3 circles in another rectangle, and we see the third rectangle with 3 circles lined top to bottom. Now we see 4 with 2 rectangles. Each rectangle has 4 circles. In the one to the left, the circles look about the same size, but in the one to the right, we have a big circle. It looks like we have 2 circles of the same size, and we have a little circle, but there's still 4 circles in the rectangle. Here we see 5 with 2 rectangles. Each circle has 5 circles. Now we see 6 with 2 rectangles. Each rectangle has 6 circles. You can color the circles different colors, or you can have all the circles looking like the same, like the rectangle on the right. Here we have Mathet 7 and two rectangles, each with 7 circles. Here we have Mathet 8. We have two rectangles, each with 8 circles. Here's Mathet 9 with two rectangles. The one on the left is somewhat symmetric, and the one on the right also has symmetry. Here we have Mathet 10. Now Mathet 10 is standing next to a rectangle with 10 circles. Notice that a 10 is made up of a 1 and a 0. Here we have the E and I building. The E stands for equalities and the I stands for inequalities. We see on the left Mathet less than, and on the right in a red spacesuit greater than. Now we see Mathet 2 standing next to a rectangle with 2 circles. Mathet 1 is standing next to a rectangle with 1 circle. Now the rectangle with the 2 circles, that black circle makes at least one more circle in that rectangle than the rectangle at the bottom. Since this is so, we can write 2 is greater than 1. Here we have 1 again with a rectangle with 1 circle, and we have Mathet 2 standing next to a rectangle with 2 circles. Now we can say that the rectangle with 1 circle has 1 less circle than the rectangle on the bottom. This tells us that 1 is less than 2. Without the spacesuits, it's written like at the bottom, 1 is less than 2. Now we see Mathet 7 standing next to a circle with 7 circles, 3 circles that are not colored on the inside, but we have 4 circles that are colored black. Now we see Mathet 3 standing next to a circle with 3 circles, and we can say that the rectangle with 7 circles has at least one more circle in the rectangle than this rectangle with 3 circles. Because of this, we say 7 is greater than 3. Now we see 5 standing next to a rectangle with 5 circles. 0 is standing next to a rectangle, and there are no circles. So that rectangle with 5 circles has at least one more circle than the rectangle with no circles. Because this is so, 5 is greater than 0. Here we have 2 standing next to a rectangle with 2 circles, and 4 standing next to a rectangle with 4 circles. Now, the rectangle with 4 circles has at least one more circle than the rectangle with 2 circles. Since this is so, 2 is less than 4. Here we have 0 and 5 again. Now, 5 is standing next to a rectangle with 5 circles. 0 has no circles in that rectangle, and so that rectangle has at least one less circle than the rectangle with 5 circles. And because this is so, 0 is less than 5. You might have noticed that less than and greater than are very related. Now we can say 9 is greater than 7, and at the same time we can say 7 is less than 9. 5 is greater than 0, and 0 is less than 5. 3 is greater than 1, and 1 is less than 3. 4 is greater than 3, and 3 is less than 4. We see Mathet 3 on the left with a rectangle with 3 circles. We see the Mathet 3 on the right with 3 circles. 3 is equal to 3. And there are 4 ways that we can write this in words. 3 is equal to 3. We can use symbols. 3 equals 3. You can write also in words 3 is equal to 3, and you can also write 3 equals 3. We see 3 standing next to a rectangle with 3 circles, and 2 standing next to a rectangle with 2 circles. Now, 3 is greater than 2, and we can also say 2 is less than 3. But instead of using less than and greater than, sometimes we like to use not equal, and that's shown in the middle. Now, 3 does not equal to 2. We can also say 2 does not equal to 3. The symbol is shown below, and you read it as is not equal to. In order to make the symbol, you have two lines across, and then you have another line that goes through them. Here we have all the Mathets from 0 to 10 lined up in increasing order. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're in increasing order from the left to the right. Now, if we were to go from the right and down to the left, we would call that decreasing order.